that's an extreme end of the spectrum. But the other scenario, I call it Mrs. Jones, where the utility comes to the Mrs. Jones home, rips the old board, put a new board with a new meter, and she doesn't actually do anything different besides paying slightly less.
Right.
And implicitly allowing the utility to even turn off individual devices at some point if there's a peak in demand.
Right.
And that has nothing to do at this point with alternative energy.
Right.
It turns out that this kind of a system, there's at the beginning it started with just a meter which is aware to the time, and a meter which is aware to the rate, and the meter actually can talk back to the utility and actually say how much was consumed,
right,
and even do prediction based on the schedule you and I set. It can actually do an aggregate across the entire city and say how much money, how much power you're going to need 3 days from now,
right,
and schedule the operation based on that, and reduce further power because you have to actually keep it in reserve, and combine with that with the weather forecast and do some other things.
Sure. Weather
forecast will affect, you know, how cold it's going to be or how hot it's going to be,
yeah,
right? And you can correlate that with predictive algorithm on past consumption. You don't have any of that infrastructure for data mining yet, but you will have to, and that's all software.
Now, isn't this all going to be?
And then, so you move from meters that just get the information to meters that report back on what they consume, to meters that give predictions, to meters that accept back price information,
right,
to a whole system that has demand response. And on top of that, once you have that, you basically have a relatively stable peak. And only at that point you can actually integrate alternative energy sources.
Right.
And the reason is, if you have mass deployment today of alternative sources, there will be no power for anybody.
The grid will come apart.
The grid will immediately collapse because it cannot actually accept the extra juice from anybody.
Right. Well, we see this already. Denmark's already struggling with this. They have so much wind power.
That's right, but they treat the entire
straining.
European grid as their buffer.
Right.
So they don't really have an issue because what they produce is relatively small to what all of Western Europe consumes.
Right.
Now, the nightmare scenario is called the Great Fire of 2018. And the nightmare scenario looks like this. We're talking about the pink unicorn scenario. Everybody has electric cars,
right,
smart meters everywhere and everything else, okay? It's Thanksgiving night, okay? Throughout the day, people were taking showers and roasting huge turkeys,
right,
consuming a lot of power. 5 p.m., everybody goes to Grandpa, and Grandpa has 3 cars garage with plugs for the electric cars. Now, to be able to have the guests drive back home, they need a 50 amp circuit.
Right.
Grandpa has 6 of them, right? The whole family is there. Everybody plugs there. What happens to Grandpa's wiring when you have 300 amps on the house? The wires immediately burn down the house, okay? Now, you could say, okay, I'm going to have just one of them at a time, they're going to spending the night or whatever, but that's again not good because that implies changes in behavior.
Right.
Even if you have the ability to rip all the walls and get new wires in there, you know, thick as my thumb to actually support this, there's only so much juice that the substation can actually provide.
Push out at any given time.
So if everybody's going to plug their cars at the same time and start having dinner, the substation would implode and there would be no power for anybody.
Right.
The only way to support that scenario, instead of having the power distributed in one place and then shifted to substation to individual homes, is have every little home with little wind, little solar, so that it won't actually put the demand on the substation. In fact, today, the current infrastructure cannot support electric cars at all, because it will immediately burn.
It's so much power.
So much power it demands.
Yeah.
The only way to compensate have the power generated locally. Only way to generate the power locally is have the smart system supporting it in the back end.
Right.
So it's all related back to the software, right? But you don't have to have any of that. You can still drive, you know, combustion cars and not have any micro generation at the residential level, and just still benefit from the megawatts effect.
Right. But what I find fascinating about this whole thing is this idea that we as software developers are we've just gone through with the whole internet revolution, everything we need to know to build this. It's a peer-to-peer networking infrastructure.
It's more than that. It's a predictive network. It's got many of the topologies that are now making some buzzwords like cloud computing and such, because cars from friends coming into your home and need to park and plug, then they would actually have their utility bills being charged, not yours. So actually connect to your system, your home operating system through the cloud, and there's some issues with security there.
Interesting, yeah.
Scalability on an unimaginable scale. Now, for this to really, because this whole thing is actually fundamentally a software problem. You could say, I mean, an analogy to the internet, and I coin the term the EnergyNet because it's so much like the internet.
Right.
The internet fundamentally is about routing TCP packets, right? There is no, you don't see eBay on Amazon at the TCP packet level, right? So there is this hardware infrastructure, the web servers that support this whole thing. That will be kind of like the smart meters and the back-end data centers that support them. But then on top of that, we have the application space, right? That where people actually operate. Now, fundamentally, the internet is about routing TCP packets, and yet we don't actually treat it merely as a communication problem. We treat it as an e-commerce problem. We treat it as a fulfillment, as trading platform or whatever, right? Way beyond the pure communication nature of it. And by doing so, the internet becomes a very horizontal thing. It actually affects the individual silos, because you have the manufacturing silo, the financial services silo, the healthcare silo, and so on. But the internet horizontally affects all of them.
Right.
And I foresee a similar thing happening here, where we're going to have this infrastructure. It's going to have some physical deployment to it and some backend and so on. On top of that, we're going to see an application space emerge. And I had, and of course, this whole thing to actually work has to be vendor independent, technology independent, meter provider independent, which means there has to be standards.
Right.
Now, the Oasis group that has been the ones providing the web services standards over the last decade totally gets it. And they're now coming up with a set of standards for the smart grid. In fact, last Friday I had a meeting with the vice chair or the co-chair for Oasis, working on those standards. There's about 16 of these standards. Instead of WS dash something, WS atomic transaction, WS secure conversation, there's SG for smart grid. So smart grid curtailment, smart grid transaction, smart grid this and that, how to transfer weather information, how to smart grid pricing. A whole set of standards is coming up, and they expect various vendors to support it. And what's nice about the way they're doing it, they recognize the fact that we don't know what we don't know. We can't foresee today what the applications would look like. It would be as if you're trying in 1992 to fathom what application on top of the internet would look like. In 1992, you cannot imagine eBay.
No.
You can't see it. So they actually believe that they need standards that would enable what they call emergent behavior. And those behavior will emerge on top of that new platform, where there's going to be even more opportunities for software developers to play. Right? And so there's some funny stories about that, because the government really wants this to happen. And so initially the government said, okay, we're just going to fund solar panels and such. But everybody said, guys,
wait a second.
Wait a second. If you do that, you're going to have to also invest in candles, okay? So they said, okay, so what do we need? We need a smart grid. So now the Congress said you have 9 months to come up with standards for the smart grid, as if you can legislate innovation, right? Which is kind of funny. So this group of Oasis that's been kind of like chugging along for years, since 2001, trying to come up with those standards and convince people, is now all of a sudden in the spotlight. And people are thinking, we've got 2 months to tell us when you're going to get the standards, right?
But it's great to see that we're now getting attention on that, and that there have been people working on this. So there's suddenly an impetus to get a specification out there and get people working from it.
It's absolutely a pivotal stepping stone. And if you think about it, that this is going to be where the next decade economic activity is going to be. We're going to move very quietly from high tech to clean tech as the economic driver of the next decade. That's where the money and the jobs are going to be. This is why you and I are active here, because we want to be where the money and the jobs are.
This is where the opportunity lies.
Absolutely.
Yuval, a great conversation as always. Can't wait to see what we do in the next 6 months.
And let me also remind that here at DevConnection, I'm giving day after tomorrow a keynote for all the attendees across all silos, ASP.NET, Windows, SharePoint, Visual Studio, about why this is a next economic opportunity for all of them to pay attention to.
You bet. Thanks for coming on.
Pleasure.